Hello and welcome back to Module 2 of this course, which is
trendily named
Creating Virtual and Augmented Reality Applications on the Windows Platform.
Fun.
Very snappy.
It is fun, actually. Let's get to it.
Yep, so this is course 2 of, there was module 2 of the course, and this is about principles of VR. So we're going to talk through, the fundamental principles that, are used in VR.
Yeah, so it's more than just dropping a plugin into a Unity project. We're going to talk about, say you wanted to build this yourself and you want to understand how it works. How would you go about doing that?
Yeah, and the first one, stereoscopic 3D, of course.
Yeah, so kind of one of the key aspects and important things for VR is to understand stereo. Obviously most human beings have got two eyes, so you actually don't spend your life looking at one picture like you would on a television. You actually see two at once. And there's an artifact called parallax, and that's basically the difference in images between your two eyes. And actually, you need to replicate that if you're going to create a kind of plausible and reasonable VR experience. So
okay, and is that what we see on this slide on the?
Yeah, so you can see.
You've got an image for each eye.
On the phone there, you've got an image for your left eye, an image for your right eye, and it's when you kind of each eye is only allowed to see those images that you perceive parallax.
Okay, and the other fundamental is positional head tracking.
Yeah, so think about Mattel ViewMaster, right? You look in, it's a really great picture, it's very convincing, it's got stereo 3D.
Yeah, I couldn't move my head around and look around inside the images there.
You move your head, completely breaks the immersion, you're no longer in a virtual environment. So it's really important for modern day VR headsets to know where the user's looking and be able to refresh that stereo image kind of 60 times or 100 times a frame or so that they get this kind of accurate simulation of, if I move my head in the real world, I expect what I see to change. Yeah, and we're going to try and copy that.
We're going to drive that from the sensors that are already on the phone.
Yeah, so
nothing else required.
We've got all the stuff already. As part of we've already got phones with clever stuff in, so we'll use that as the tools.
So, are there any other aspects? I guess it's much more complicated than that. We're just going to look at the very fundamental elements.
Yeah, it's about basic elements. So you go much further on into when you're looking at high-end headsets with room position tracking and research stuff where you've got all these additional things that are about sound and smell and that kind of things. But
for the time being,
for really simple, let's talk about head tracking and let's talk about stereo rendering, because actually your brain likes to understand what's going on and it's quite good at filling in the gaps. So if you give it something reasonably plausible, it'll come up with a good image. So back to kind of stereography and how we render that. So most human beings have got two eyes, and a really great experiment that I like to do, and you should try and do it as well. So you stick your hand out in front of you like this and stick your thumb up. And then you close one of your eyes. So if you close your left eye and then close your right eye and do that over and over again, you'll see that your thumb moves by about an inch in front of you. And that's a really good representation of the two images you're actually seeing that are different. You don't notice this in the real world because your brain stitches the two of them together into a single image with depth. And so what we're going to be trying to do in the game engine is we're going to take kind of the two renders side by side, which have a slight distance between them, to simulate that kind of inch or so disparity between the two things that we see.
Okay, so like mimicking the real eye and head setup.
So virtual reality is all about copying the real world and copying how you would perceive it. So everything that we're going to do from now on is about trying to create a data representation of something that really exists.
Okay, so before we do that, I think we should put a post-it note over this girl's eye.
I think that would look.
Do you think that would?
That's quite a good.
Should we try that?
Quite a good simulation.
There we go.
Yeah. So now she can't see depth, and that's what's great is her brain will still fill in the gaps. She'll still see an image, and she'll probably see depth as well because her brain will use other things like the movement of her head and to achieve parallax.
Yeah, I mean you're not suddenly going to forget the size of things. Just because you've covered one eye, right?
Yeah. So that VR can be fairly forgiving, can be fairly unforgiving. Where depth is concerned, your brain's very, very good at filling in the pictures because you need to understand depth because it's one of your important survival senses. So I've got this really nice lacking of information drawing that I've drawn. So if we have a look at this, what this drawing represents is a pair of eyes at the bottom with the distance between them.
Yeah.
Human beings, the distance between the eyes is usually 60 millimeters. So if you need to program it in, human IPD is almost always 60 millimeters unless you've got a really wide head or a really small head. But most people feel comfortable viewing stereo that has that distance. So we've got these shapes at the bottom which represent the eyes and their field of view. And then we've got two X's positioned in the middle at the top and in the middle. They represent two different objects which are kind of placed one very close to your eye and one further away.
Yeah.
And what we're going to represent in the next slide with the angles that I've drawn on is the difference in what's called incidence angle. So the incidence angle is the angle at which the two kind of lines cross to form a triangle. So objects that are far away, and you can demonstrate this with your arms. If you push your arms far away, the angle between your body and your arms is quite acute, and then the closer you bring it, they get shallower and shallower and shallower. And what your brain
makes
is
sense.
doing is it's comparing those angles to tell you how far away it is, because it knows how far apart your eyes are. And that's what we're going to try and simulate.
Yeah, so we can kind of trick the brain into thinking things are further away than they really, well, they're actually there just on the screen in front of your face.
And the way that you do that is by changing the angles at which you perceive them. So, yep, let's go on and build it.
Should we switch over to, let's switch over to Unity and do a demo.
Super simple.
We're going to show you how to create a stereoscopic view, just a basic stereoscopic view inside Unity.
Yes. Unity is a good tool of choice for this because it simplifies away a lot of the 3D stuff. So you can just think about principles. There are people who like, I know, to build their own engines in X and A and C++ and that kind of thing. And while commendable and useful for some things, if you want to pick up a demo, and especially if you're at a hackathon or a game jam, just use a game engine that already exists, because there's nothing in this kind of principle of VR that doesn't already work with existing game engines.
Okay, so I'm going to come and create a new project.
Yep.
What should we call it? MVA demo?
Creating virtual and augmented reality applications.
No, I can't type all of that in. I can't even remember what that is. Okay, so we're just going to create an empty project.
There we go.
And if you're not familiar with Unity, this is the free version of Unity. You can go and download it from the Unity website.
Yep.
And what we're seeing here is we see a 3D environment at the top, and we're seeing a kind of game rendering at the bottom there.
Yes. So Unity is basically building up a scene from mathematical positions. So in the top you arrange things in this 3D space, and then at the bottom it renders it onto the screen.
Yeah, so I'm seeing a kind of perspective view.
Yep.
Looking at my scene, and you can see inside the scene we've got a camera there.
Yep.
That's our main camera at the moment, and there's also a directional light.
Yep.
And I think we've got a view box defined, haven't we, in there? So what I'm going to do is I'm going to import a custom package that we've prepared earlier with a demo scene inside.
So yeah, all this content that we see on the samples, I'm going to be putting up on VISRVR.com/developer, so there'll be all of this kind of material to download.
Okay, let's just import the package.
Yep. And
inside that package I've just imported, I have a prefab in here, which I can just drag into my scene, like so.
And a nice room.
And there we go. There's our little demo scene. Do you want to just tell us what the scene is? Yeah,
so it's quite a nice little environment for testing VR in, because you've got some things that are close to you and things that are further away from you, and we've got some physics objects in, which we'll see later in our SDK demos that we're going to play with. And so it's a simple concept. You're in a square room, you've got some stuff you're going to interact with, and that's kind of one of the key things to think about when designing for VR. And again, we'll touch on that later, is just keep it really simple, especially on phones where performance is far more important than visual fidelity.
Okay, so what I'm going to do is I'm going to take a copy of our main camera.
Yeah.
So we've got two cameras now in the scene, and I'm going to rename this one as left eye, which kind of matches up what we spoke about earlier. So we're trying to mimic those two cameras as one per eye.
Yes.
Let's just drag that up to the top, and I'll rename this camera as the right eye. If I could hit the keys properly. There we go.
What I usually do at this point is I'll actually go up to game object at the top and create a new empty object and drag them both in, so that you've actually got one.
I can do that now. Or I usually do that with when I start to build up the head tracking.
Yeah.
I could do it now though.
Well, let's build it for now, just so people are kind of familiar.
Okay.
With
Yeah. Let's add a great game object in here.
And I'll show you the secret trick of why we've done that in a minute, because there's actually something that makes this camera alignment a lot easier.
Let's call that VR camera. Now, in this hierarchy, if I set these other cameras as children, then if I apply a transformation to the parent, then it's hierarchically kind of composed down to the children. Right?
Yes. So if you imagine the concept for that is, if I have a bag, I put a load of things in the bag and then move the bag, all the things that are in the bag move. And so we're doing the same kind of idea with this.
So there we go.
Yep.
I've parented those two eyes.
Yep.
And let's just reset this to 0, the Z coordinate of each eye. So we're basically just setting the eyes back to the origin.
Yes.
And then we'll use the parent to position.
Yes.
Right. So that's kind of quite neat. So let's put that there, and then I'll just I'll move them back out to -10 in the Z axis by moving the parent. So there we go. We're back to where we started. But we're not really seeing a stereoscopic view yet. So, so let's fix up the viewports so we do. So if I choose the left eye, and I change the width of the viewport to be 0.5, and if you just watch down here in the bottom of the screen, then you can start to see two views.
Yep.
So let's select the right eye.
Yeah. Anyone familiar with 3D graphics will know that this is called the view projection, and that the whole screen is represented by a square. And you've got 0, 0 in the top left and 1, 1 in the bottom right. So what we're doing here is we're changing where in this viewport rect, as Unity calls it, the camera is actually rendering, and that's a really useful feature. And what's great about using a game engine is all that stuff's kind of exposed. Yeah. So if you know it's there, you can use it, and we haven't had to write a line of code, and we've already got pretty good representation of 3D rendering. Yeah, so there you can see the two views, one for each eye. Yep. And because we've done the parenting here with the VR camera, if I want to rotate the view, yep. Let's just rotate it about Y. As I do that, you can see that what we're doing is effectively we're turning our head from left to right. Yep, looks good to me. Okay, so that was a nice illustrative demo inside Unity. It's nice and simple to implement. That's what I like about it. You can get something that looks very reasonable in very little time. Yep. But it does have a few reasonable problems. being the key word. So there's a few things that you have to watch out for when you're rendering stereo. So, actually human vision systems are incredibly complicated, and still to this day we don't. People go blind in one eye. We can't just build a replacement. It's a very complicated organic system. Works in two ways. So you can work in your favour because it's always keen to perceive, and your brain wants to see. Sometimes it can look really good even when it's a terrible rendering. Sometimes it works in completely the opposite reaction, where your brain actually feels under threat because it can't understand what's going on, and that's when you end up with people feeling sick and getting nauseous and things like that, because it's trying to comprehend what's happening. Kind of more physical aspects, problems that you have. So if you look at a headset like this one, you've got the lenses inside, and what they're doing is they're taking the flat image of the screen and they're bending it into a sphere around your eyes. That's what the colamination part of a colaminating lens is. Yeah. A good kind of analog to that is a fisheye lens does the opposite. A fisheye lens is taking the world around you and it bends it down onto a square sensor at the back of a camera. And you get something called pincushion distortion. You can see that in that picture on the bottom right. So if you look at the picture, that is actually a photograph of a building with square windows. And what's happening is towards the periphery of the image, because that's where the picture is getting warped the most, as it gets kind of squashed down into this flat format. You end up with the lines being bent in spherical directions. So how do we deal with that? Because that's not going to make a very pleasing game if it's all kind of warped like that. It's not easy to make go away, but we've got the advantage of being able to manipulate the image that goes in. So if you're a photographer, you're taking a picture of the building, you can't change the building to be the opposite of the distortion. But because we're computer scientists, we control the light that comes out of the screen. The really simple solution is you produce the opposite. So if you imagine it was kind of two radio signals, one of them's got a lot of noise in it. The other one's got noise in completely the opposite direction. You imagine you combine those two signals together
Cancelling
and you get nothing.
Effect.
So, the opposite of pincushion distortion is called barrel distortion. Yeah. And what we do is we apply barrel distortion to the images that come out of the screen. They're then distorted in the opposite direction by the pincushion in the lens, and you end up with a good-looking image. Great. So it's a John Carmack technique, so it's kind of classic Carmack. It's a really simple solution, but it works. Yeah. So we've got some other issues as well, of course, like chromatic aberrations, where some of the light gets separated. Yeah, so you end up with a prism effect. So what happens is, if you imagine the middle of the lens is a point, blue goes this way and green goes the other. It's red and green go. They rotate around the middle. I can't remember the physics. But basically, you end up with color splitting, and it gets worse the further you get to the edge. You correct that in exactly the same way that you would the barrel distortion, the pincushion distortion. So you shift the colors in the opposite direction before they come out, and then again when it's combined, it looks neat. I see. I see. So there's quite a few things that we, if we're going to build a real SDK. Yeah. That there's some science in there. You've got to, there's probably 6 months of learning and research of someone who figured out that was going to happen like that. And but the nice thing is, again, you can start from simple base principles and take that wherever you want to go after that. Okay, so let's talk about head tracking. Yeah. So this is kind of the other important key point is head tracking and how we do it. So we've got this situation where you need to update and refresh the image per frame, so that when the user's head is moved, this binocular pair that they were looking at in that direction is now moved into that part of this 3D world that they're in. And we do that based on 3 key sensors from the device. We've got a gyroscope, an accelerometer, and a magnetometer, and they all provide some kind of hint as to what direction the phone is looking in. And the great thing is, with Windows 8 and Universal App Platform and things like that, there are really good APIs sort of already wrapped around those that you can tap into.
So we can actually just get at the end of it an orientation.
Yeah. So there's complex physics involved in actually taking all these readings and combining them into a 360 degree by 360 degree 360 degree direction. But a lot of that is handled by the platform for you, because those, going back to the first lectures where we said smartphone industry is really driving this. Those information are required anyway by smartphone apps. So most of the tool publishers, you can find similar APIs on Android and iOS, but the Windows API implementation is particularly nice. We'll just give you that angle at the end, and then you can just use it.
Yeah, so most of the hard work in that has been done. So if we have a look at some of the programming model that's involved in that kind of thing. So on Windows 8.1 we had this kind of motion class.
Yes.
Which embodies all of that.
Yeah, so this is kind of a complete sensors motion state, and it will do all of the interpolation and gravity offset and all the other stuff that you need to do when you figure out an accurate gyro reading for you. So you literally just create this motion object and subscribe to a value changes event, and then when the value changes, like you've tipped the phone, it'll inform the application.
So I'm getting back now. I'm going to give back values like roll, yaw, pitch.
So it's pitch, yaw, and roll, which is always great to do with your hands. So you've got pitch, yaw, and roll. And what's interesting is the reason that you'll see kind of 3D mathematicians will sit at the desk kind of doing this is they happen in that order.
Yeah.
So back to 3D render, you've got to remember that they happen in that order. If you're trying,
if they go in a different order, then you get a different result. Right?
Yeah. So if you imagine we've got pitch, yaw, and roll, but if we rolled and then we pitch and then we yaw, or you're going to be looking in a completely different direction.
You're doing some body popping.
Yeah. And I'll just.
Okay, so this is an older.
We have a new way of doing it
object.
now.
So with Windows UWP, Universal Windows Platform, we've got 2 different objects. So we've got the inclinometer.
Yeah. So inclinometers are really good fallback for devices that don't have a gyroscope. So most of the kind of the 5 series and the 520 series of the kind of the Lumia phones that are coming out, they're the basic package ones. So they actually struggle to support VR in the way that you would on a full-fledged kind of Premiere device. However, most of them still have an inclinometer, which is based on other readings from other sensors. So if you are stuck with a phone that doesn't have a gyroscope, you can use the inclinometer to sort of get a reading of where you are.
Yeah, and the programming model is pretty much the same, right?
Yeah, so you've got a provider which you get from a singleton somewhere, and then you subscribe to an event for the value.
Yeah, and we're getting back roll, pitch, and yaw again.
Yeah,
and then we've got the orientation sensor, which gives us different values, doesn't it?
Yeah. So this is the kind of the Premiere sensor. If you're using a Windows Phone or a flagship device that has all the sensors in, you want to be using the orientation sensor.
Yeah.
And it's kind of the same as the motion class on 8.1, where you've got, all of the complicated maths has been bundled up for you. You fire off an orientation sensor object and you receive the readings. The only kind of key point is you don't get back your pitch roll, because actually, for people who've watched Apollo 13, they have this. They're scared of getting into a situation of gimbal lock. And what gimbal lock is, where if you imagine you have this your pitch and roll, if you do it in the wrong order in such a state that you yaw all the way to the top, so that your pitch has no effect and then your roll has no effect, you actually the thing becomes unstable. It doesn't work properly.
You can end up with just 2 degrees of freedom, because you've kind of locked.
Yes.
You've locked 2 together effectively at that point.
And so you lose tracking and your users feel sick and all that kind of thing. So to avoid that, going back to kind of orientation sensor being the more snazzy one, that actually has a different way of representing rotation. It brings back a quaternion object, which actually uses imaginary mathematics. And is very complicated.
We won't get too much into that right now.
But you can just throw that into Unity, because Unity has a receiver for that. So, for those of people who want to go and look at how quaternions work, very nice, very interesting. For kind of both of us, we just take this value, it's 4 numbers long, and we're going to feed it into Unity and do something with it.
Yeah, so it's a really nice, simple programming model. If you want to see some samples, then you can go along to the Windows Universal samples on GitHub, and there's a couple of sensor samples in there.
Yeah, there's loads of stuff in there, so it's kind of pick and choose from there, kind of what you need to make it work is my usual tactic with Windows. Okay,
so that's how you do this on Windows.
Yep.
Obviously, that's not a cross-platform solution.
No, but it is quite nice. But what we're gonna use for this demo we've got coming up is actually the platform within Unity that just brings you back sensor values. So that's a nice place to start. It's good to know about the kind of more elaborate sensor stuff if you want to do something really kind of special. But actually, Unity's got input.gyro, and you can just pull information out of that, which is what we're going to be doing.
Okay, so shall we switch over to Unity again and do a demo of that? Okay, so the first thing to check then is that these eye positions are set to 0.
Yep. So
they're positioned on 0, and then the parent we want for this demo want it to be in the middle of the room.
Yes.
Right. So we move that to 0 in X, 1.9 in Y, and 0 in Z.
Yep. The 1.9 is quite important because actually 1.9 is 1.9 meters in Unity. And this is one of the things that you've got to kind of keep a grasp on is when you're doing virtual worlds, you should try and use real units when you can. So, a lot of people do little space games where they've got 300-mile long ships that are represented by 2 or 3 units in the game. But actually, when we're doing virtual reality, mega important that we use actual units. So 1.9 being the average height of a human being.
I guess it would make you feel either bigger or smaller than
so it'll change your...
somehow out of proportion.
Yeah, we'll go into it in game design later, but it's important for this demo. So remember guys, real sizes, real world objects.
Okay, and now the way that you interact with objects in Unity is you create scripts.
Yes.
Right? So I'll create a C# script. Let's call it head tracking. If I could spell, there we go, head tracking.
Yep.
And I'm going to associate that script with our VR camera. So I'll just drag it on there and drop it on top. And if you click on there, then you can see in the inspector, you can see that script is associated with that object.
It's usually grayed out when you start because it's compiling, so you've got to edit it and put some code in first. So don't worry if it's grayed out. It's supposed to do that.
Yeah. Okay, so if I double click it, I've got Visual Studio set up as my editor. So that's going to open Visual Studio and it's going to open up this script ready for editing. So what we see is we see a mono behavior and then my head tracking object.
Yep.
We have a start method and an update. So start's going to be called once at the start, and then update will be called every frame.
Yes. So start, you generally set up the stuff you want to use, and then you use it in the update method.
Yeah. So I'm being a bit lazy. I've got a few snippets in here.
Okay.
I'm just going to drag some member variables in, and then we'll talk through each snippet as we go.
Yep.
So first notice we've got a gyroscope object, and that's kind of Unity's abstraction over the sensors, right?
Yeah.
So that will work across platforms.
Yeah, so no matter what platform you're on, Unity will provide a gyroscope adapter for you to talk to the gyroscope on whatever phone it is you're using. Yeah,
and we've got this initial rotation, and we'll show you what that's for in a minute.
Yeah.
It'll become clear. So let's bring in the body of our start method, and I'm just going to drop that inside there. Let's see, we're just setting the screen to not time out.
Yeah.
And we're saying if the gyroscope is supported, because remember we could be running inside Unity, inside the Unity player, not on a phone, so there may not be a gyroscope.
It would explode.
So we're just enabling the gyroscope with the next line, and we are capturing the initial rotation of our object that we're associated with.
And that's important because if you pointed the camera in another direction in your scene and you want the user to start off looking in that direction, it might not necessarily be 0, 0, 0. You might be looking 90 degrees to the right.
It's like this is my home position that I'm looking at.
Yeah.
Right? Okay, so let's bring in
the magic.
Yeah, this is where all the magic happens in here. So what we're saying is if the gyroscope is supported, let's just talk through this a little bit. So this is saying that if you touch the screen, then your position will go back to home.
Yes.
That we spoke about, that we captured earlier.
And that's important because you might have actually, somebody picks the device up, has a go on it, turns around and puts it upside down on the table, and by the time somebody else picks it back up, it's kind of drifted away from where it was, and someone might then pick it up and be looking in the wrong direction. So, basic VR design principles, it's always useful to have a way for the user to reset.
Yeah, so I can recalibrate to this position, and then everything's based upon that.
From there.
So then we've got this is where the real meat of this, right?
Yeah.
Right. So we're getting rotations every frame.
Yeah.
Kind of delta rotations.
Yeah. So you get a rotation speed. That's what a gyroscope actually measures.
Yeah. And we are applying that to so we're multiplying the current rotation by that delta.
Yes.
So effectively we're just moving a little bit.
Yes.
Depending
a little
on
bit on every, and then next frame we're going to measure how fast we're moving this time, and then apply that. So it's kind of, we're taking the speed, then we're turning that real life speed into a speed in the game. That's what the time.delta of time is for. And then we apply that to an existing rotation. So we've got our current one plus another little bit, and then that gives us the overall rotation.
Yeah. Okay. So I'm feeling quite good about that script.
Yeah.
So let's just hit save on there.
Dangerous words.
It's always I'd like to live on the edge. So what we could do now is what we want to do is we want to put that app on to my phone.
Yeah.
So we need to do a bit of work inside Unity here. So if I come down to the build settings for the project,
yeah,
and there's a lot of different platforms in here. It's quite staggering, really. Yeah. You know, there's a whole list of them there.
There's quite a lot of work represented there, I think.
We're going to choose Windows Store, and I'm running Windows 10 Mobile on my phone there.
Yeah,
that's a Lumia 950.
Very nice.
And I'm going to choose the Universal 10 platform. That's going to be a XAML app. I'm just going to use those in case I need to debug it.
Always good. And actually, if you enable Unity C# projects, you can fiddle as well with the build just before it's deployed, which is useful if you're
that's quite a good tip actually, because you can then go and change without going back into Unity to rebuild everything every time, which is a good big time saver. It's
one of the nice things about the Unity tools for Windows Store, particularly, and not the other platforms. You know, if you're on iOS and Android, it gets compiled into C++ and then chewed away from you. Whereas Windows supports C# as one of its core languages, so you can just use it as it is.
Yeah, it gives quite a bit of flexibility, doesn't it?
Yeah, no, it's cool.
So I'm just going to add our current scene.
Yeah.
So I need to save it. I need to give it a name. Let's just call it main. And one final thing I want to do, and it's interesting to note actually that there's a whole load of player settings here. So you can set up splash screens, icons for your Windows app right in there. And there's a whole load of other settings that you might want to have a look through. I'm just going to fix the default orientation to landscape left.
Yeah.
For this
Which
particular
is important
demo.
for the sensors.
It is.
So yeah, one of the things you've got to remember when you're talking about sensor interaction is actually, in software we tip the device and the landscape and the orientation of the device changes and they move all the graphics. The physical gyroscope that's soldered onto the board isn't going to move. So if you move it, it's actually all wrong, and you've got to remember what orientation you're in and kind of reset it.
Yeah, you can you can confuse yourself, can't you?
Yeah.
Whilst you're programming this,
so
if you keep switching the orientation.
Yeah. So in our example, we've hard coded them to support landscape left, but if you want another orientation for some reason, you'll have to kind of flip some of those values around and do a bit of fiddling.
Okay, so I'm now going to build, and what build means in this context is that Unity's going to build us a Visual Studio project.
Yeah.
Right. So I'll just create an output folder. Output. I shall select that. And Unity will go and do its thing. It's going to build me a Visual Studio project that I can then go and open in Visual Studio. And it's just it's a Windows UWP app.
Yep.
And I can, as usual, I can build it in there and I can deploy it to my phone.
Yep. So anyone familiar with the app workflow for Windows, you're now back in familiar territory and you can just deploy the app as before.
So that just takes a minute or two. Let's go back, see if that's done.
We need some elevator music.
It's copying player files at the moment. What does it do next?
Don't know. It should be done by now.
Reticulating splines or something.
What is it? It's filling swimming pools.
There we go. So it's popped open Windows Explorer, and if I dive down into output, then I can double click my solution and it will open up inside Visual Studio. We can have a look at it. Okay, so let's just have a quick look in here. I've got a few projects here, which these are the ones where our scripts are compiled into.
Yeah.
So in here I can edit them and rebuild.
Yeah, Unity interestingly compiles in 3 goes. So it'll compile the code once into a DLL. Then it will include that DLL into a project and compile it again, so you can compile stuff that's based on what's called a reflected assembly before, and then that final assembly is bundled into a Windows Universal app.
So what I'm doing now is I'm just deploying that to my phone. Let's just unlock the screen. That's just going to take a few moments to build and deploy.
We'll see how many times we can read creating virtual and augmented reality applications on the Windows platform.
Maybe we can try and think of some other title for that. It's a bit snappier.
Yeah.
We could put some acronyms in.
Yeah. CAW on the Windows platform.
Okay, I think it's nearing the end of the build.
Registering the application to run from layout. Interesting stuff happening there.
There we go. It seems to be doing something. The screen on my phone has just changed to black. And we should momentarily see the Unity screen. And then once the app's deployed on there, what I'm going to do is I'm going to switch over, because we have here a Continuum dock, and this 950 works with Continuum. So I'm going to plug the phone into the dock, and then we should be able to mirror its screen to the display.
So the lovely people at home can see.
So you can all see it. And I can put the headset on, and we can actually see the head tracking working in a real sort of VR environment.
This is quite a nice, kind of just before we jump into that, because we deployed the app on the table. If you actually, can they see the screen? Or have you reset it now?
I've reset it, yeah.
I know, we'll cut that away. But I was going to say, now this is why you would want to reset it. But
yeah, so it was pointing up in the sky. It was lying down on there, and it kind of drifted off a bit. So when you hit the screen, it just resets.
Yeah.
And as I tilt the phone up and down, you can see the movement there.
Yeah.
So what I'm going to do now is I'm just going to stop that app running on the phone, and I'm going to plug the phone into the Continuum dock.
Yeah. And then the magic one.
What can possibly go wrong?
It's your Steve Ballmer moment.
Okay, that should automatically detect it's been plugged in. Or do I need to go across and start the Continuum app at this point?
We got any video output?
I think I need to. I need to select the Continuum. Last time it automatically started. But okay, I just need to change the display settings, because I'm actually in full Continuum mode, where I can see kind of desktop style apps coming out of the phone. So I just need to change these display settings to mirror what I'm seeing on the phone. So it's in advanced settings, mirror what's on my device. And there you go. Now you can see my phone. And let's just restart the demo.
So I've got behind me a cardboard VR headset. Here's one I made earlier.
Okay, so I'm just going to run the demo. So that'll take a few moments to start, and I'll place the phone. Let's place it inside this one.
Yeah. So this is one of our developer devices on our website. Not that I'm trying to sell them.
Okay, so I've just placed the phone in. Oops, it's a bit top heavy now, but I've placed it in the end of there. And let's just wait for the splash screen to come up.
Let's see what happens.
It's on its way. There we go, made with Unity.
Yeah.
And you can see now on the screen what I'm seeing if I look through these lenses, which I'm going to now do. So let's have a look around. Let me just calibrate it. So I'm just going to go to the home position. And I'm just going to have a look around inside this scene. I can see some kind of bottles sitting on top of there. Yeah, it's quite nice. It's fooling my brain into seeing those things in 3D.
Yeah. So as you can see, kind of we've gone from kind of very, very basic first principles to rendering something that's reasonably comparable to, you know, you'd see a VR demo run by another VR company, you still get that side-by-side image rendering and head tracking. So, you know, we've got something that looks fairly good in not very much time, and it's kind of cool that we can introduce them in this way, because now, you know, when you're at home see things implemented in this way, you'll understand some of the science behind why that's been done as it has.
Okay, so back to the deck.
Yeah. Oh, that was good.
Yeah, I quite enjoyed that demo. It's nice to see it actually in action there.
Yeah, that's cool. So,
so should we talk about some of the other toolkits, or some toolkits that you can get now that are available?
So there's quite a lot of stuff that's kind of been put out open source, or that's other companies that are trying to support this that they've put out. So the main one that's sort of the most popular at the moment is the Google Cardboard kit. Yeah. Which doesn't work on Windows, so that's not one that we can recommend because it doesn't run on the Windows ecosystem. But there's a great open source community of people who are looking to support this. You know, we've got Fibram from earlier; they've got an SDK which runs on Windows Phone. There's an open source program called Alps VR and another one called Universal VR. So kind of people in the in the maker community, and because these devices are so easy to make, you'll find quite a bit of software that's out there that will support your endeavours.
Yeah, and the Alps VR one is because it's open source, and Microsoft employees have contributed and made it work with Windows Phone, which is quite nice.
That's very nice. I think we helped with some of that back in the early days as well. So that was our MS Ventures tenure. We kind of assisted with that. And then moving on to my shameless plug.
VISR VR SDK.
Yeah, so VISRVR.com/developer. We're going to be putting up all of the material that you've seen in this MVA. We're also going to be pushing up all of the source code for our SDK that we've built, especially for the Windows platform, but is also cross-compatible with other platforms. So it's kind of a really good toolkit to jump in and start building VR experiences.
Yeah, and we're going to show that in one of the later modules, right? Yeah,
so we'll do a demo where we build an environment with that and talk about how that's slightly different to other SDKs and the kind of things that we're looking to support in the future.
Yeah.
And how by building that you can kind of future-proof yourself against kind of cool new features that we're going to have.
Yeah. And what happened to the waistcoat?
That was about 10 years ago.
Okay, so would you like to summarise that?
Yeah, so kind of we've come up with some really good understandings of how this sort of works, how you start to put something basic together. So, it is actually pretty easy to put it together yourself. You can build a VR experience from nothing and get something reasonably comparable working in a short amount of time.
Yep.
You can work with SDKs that are pre-existing. Unity is very helpful with this. The Microsoft toolchain is very helpful. But use an SDK, because now you sort of understand the core principles. There's no need to build this yourself, and it's often very tempting as a software developer to do so. But there are people who really understand this, who've put toolkits together. Go and use our one that our engineers have built. Use the Albus one. Use one by Google. Someone where someone's put a great deal of time and effort into the more complicated sciences of it. It's not core to your ability to build an experience that we do that. So I'd say go for an SDK.
That makes sense. I mean, understand it.
Yeah.
But then take advantage of work that others have done. Yeah. So that kind of brings us to the end of Module 2. Hope you've enjoyed it. And we'll see you in Module 3.
See you in the next chapter.